James Webb was never supposed to look at Pluto. Not seriously, not up close, and definitely not in a way that would leave scientists rewriting what they thought they understood about the coldest, most distant world we've ever mapped. But it did. And what it found sitting on Pluto's surface and hiding inside its atmosphere is something so strange that researchers are openly admitting they don't have an explanation for it yet. Stick with me for the next few minutes, because this is one of those rare stories where the deeper you go, the stranger it gets. And by the end, you'll understand why scientists are calling Pluto one of the most bizarre worlds in the entire solar system, hiding in plain sight for decades. Let's start with why this shouldn't even be possible in the first place. Pluto sits nearly 3.7 billion miles from the Sun. It is small, dim, and incredibly far from Earth. So far that sunlight takes over 5 hours just to reach it. For most of its history, Pluto was basically a blurry smudge in our best telescopes. Even the Hubble Space Telescope, one of the most powerful instruments ever built, could only capture Pluto as a handful of fuzzy pixels. Then in 2015, NASA's New Horizons spacecraft finally flew past Pluto up close, and it changed everything we thought we knew. Instead of a dead, frozen ball of ice, New Horizons revealed mountains made of water ice, a heart-shaped plain of frozen nitrogen, and a thin, hazy atmosphere nobody expected to be so complex. But New Horizons could only give us a single flyby, a quick glimpse before speeding off into deep space forever. It couldn't stay and study Pluto over time. That job would eventually fall to a telescope that wasn't even built to look at Pluto specifically at all. If you're new to this channel, we cover discoveries like this every single week. So go ahead and subscribe now, because what James Webb found next is where this story turns into something genuinely unexplainable. James Webb Space Telescope was designed primarily to study the oldest galaxies in the universe, distant exoplanets, and the earliest light from the beginning of time. Pointing it at a small, cold dwarf planet in our own solar system almost seems like a waste of its capabilities. But scientists realized Webb had something no previous telescope pointed at Pluto ever had: extremely sensitive infrared instruments capable of detecting wavelengths of light that had simply never been measured on Pluto before. Using its mid-infrared instrument, known as MIRI, Webb was able to do something remarkable. For the very first time, astronomers could separate the heat signals coming from Pluto and its largest moon Charon individually. Every previous infrared observation, going all the way back to instruments launched in 1997, had blurred this two bodies together into a single fuzzy signal. Webb's optics were sharp enough to finally tell them apart. And what it found first confirmed something scientists had only theorized nearly a decade earlier. Back in 2017, a planetary scientist proposed that Pluto's thin atmosphere might contain a layer of haze so effective at radiating heat into space that it was actually cooling the entire dwarf planet down. At the time, there was no way to prove it. The theory sat untested for years. Then, Webb pointed its infrared eye directly at Pluto, and the faint infrared glow of that predicted haze layer showed up exactly where the models said it should be. The scientist who made that original prediction admitted it's rare in planetary science to see a hypothesis confirmed this precisely and this quickly. That alone would be a solid discovery. A hazy sky, similar in some ways to smog here on Earth, quietly regulating the temperature of an entire distant world. But that haze turned out to be doing something even stranger than just cooling Pluto down. Webb's data revealed that this high-altitude haze is actively kicking methane and other organic molecules out of Pluto's thin atmosphere entirely. And here's the part that sounds almost like science fiction. Some of those escaping molecules aren't simply lost to space. They're being pulled across the gap between Pluto and its largest moon, landing on Charon's surface instead. Scientists have started describing it as an atmosphere spilling from one world onto another, a kind of planetary transfer that doesn't happen anywhere else that we know of in the entire solar system. Think about that for a second. Pluto is essentially breathing its own atmosphere onto its moon, redistributing material across nearly 12,000 miles of empty space in a slow, continuous process that has probably been happening for millions of years, completely unnoticed until now. And Charon itself turned out to be hiding secrets of its own. Using Webb's near-infrared spectrograph, researchers detected carbon dioxide and hydrogen peroxide sitting right on Charon's surface, chemical signatures that had evaded every previous instrument ever pointed at the moon since its discovery back in 1978. These compounds may hold clues about how Charon actually formed, whether from a massive ancient collision or some other violent process billions of years ago. Scientists say these chemical fingerprints could help settle a debate about Charon's origin that has lasted for decades. For nearly 50 years, Charon sat there in our telescopes and spacecraft images, studied again and again, and still managed to hide two entire chemical compounds from every instrument that came before Webb. That alone should tell you something about how much we still don't know, even about objects we've already photographed up close. Researchers involved in this study have said Charon's chemical inventory is now more complete than ever before, but they've also been clear that gaps still remain. Wavelengths. Webb hasn't fully explored yet, and future observations may reveal even more. But none of that compares to what came next, because this is where things stop making sense entirely. Earlier this year, a team of researchers analyzing Webb's spectral data noticed something odd buried in the light bouncing off Pluto's surface. A very specific, narrow dip. In the spectrum, centered at a wavelength of just over 5 microns, a part of the light spectrum barely explored on Pluto before Webb existed. This dip means something out there is absorbing that exact wavelength of light, which usually points scientists straight toward identifying a known chemical compound. Every molecule absorbs light in its own unique fingerprint pattern, so normally, finding an absorption line like this is the easy part of the puzzle. Except this time, nothing matched. Researchers combed through spectral libraries containing known ices, including ethane, ethylene, acetylene, propane, benzene, and hydrogen cyanide, chemicals already confirmed to exist in Pluto's environment. None of them lined up with the signal Webb detected. The absorption simply didn't belong to anything in the known catalog of solar system chemistry. Then something even more unusual happened. The exact same unexplained absorption signal showed up again, this time on Titan, Saturn's largest moon, a world separated from Pluto by roughly 1 billion miles in completely different environmental conditions. On Titan, the signal appeared with a depth of around 6 to 7%. On Pluto, the signal was present too, but nearly 3 times wider, with a slightly shallower depth of 4 to 5%. Two completely different worlds, orbiting 2 completely different planets, sharing an identical, unidentified chemical fingerprint that doesn't match anything in the known scientific record. Researchers involved in the study said plainly that they could not find any previously published absorption band that corresponds to this exact signal on either world. In other words, this appears to be evidence of a molecule humanity has never directly identified before, quietly sitting on the surfaces of 2 of the most distant alien environments in our solar system. Scientists have a few working theories. One possibility is some kind of complex organic compound formed through unique chemical reactions triggered by radiation and extreme cold, conditions that simply don't exist naturally here on Earth. Another possibility is that both worlds happen to share some rare frozen molecule that has simply never been studied closely enough anywhere else. The difference in width between the 2 signals might hold the key, potentially revealing clues about temperature, surface texture, or ice grain size on each world, but right now, that's still an open question actively being worked through by researchers. It's also worth noting just how unlikely this overlap actually is. Titan and Pluto could hardly be more different from each other. Titan is a massive moon wrapped in a thick, orange, nitrogen-rich atmosphere, orbiting a gas giant nearly 1 billion miles closer to the Sun than Pluto. Pluto, by contrast, is a small, icy dwarf planet with an atmosphere so thin it would barely register as a whisper compared to Titan's dense haze. For 2 worlds this different, sitting in such different regions of the solar system, to share an identical unexplained chemical signature suggests whatever this compound is might form under a surprisingly wide range of conditions, or possibly points to some shared process neither world's environment can fully explain on its own. If you're the kind of person who loves discoveries that blur the line between hard science and full-blown mystery, hit that subscribe button right now, because this is exactly the kind of story we dive into every single week on this channel. What makes this discovery even more remarkable is the sheer distance and difficulty involved in detecting it at all. Pluto is so dim and so far away that even gathering enough light to analyze its spectrum in this level of detail was considered nearly impossible before Webb existed. Yet here we are, examining chemical signatures on a frozen world billions of miles away, precise enough to say with confidence that something out there simply doesn't match anything currently known to science. And this isn't the only surprise Webb has uncovered about Pluto's atmosphere. Earlier observations revealed something researchers are now calling an entirely new kind of climate system, one unlike anything else found anywhere in the solar system. The interaction between Pluto's haze, its escaping atmosphere, and its gravitational relationship with Charon creates a feedback loop that has no direct comparison anywhere else among the planets or moons we've studied. Some scientists believe understanding this bizarre climate could even offer clues about what Earth's atmosphere may have looked like billions of years ago, back before oxygen existed, when nitrogen and hydrocarbon chemistry dominated our own planet's early sky. So here's where this leaves us. A telescope built primarily to peer at galaxies from the dawn of time turned its instruments toward a tiny frozen world on the edge of our own solar system and found evidence of an unidentified molecule that doesn't belong to any known category of chemistry, sitting quietly on 2 separate worlds separated by nearly 1 billion miles. Researchers are still analyzing the data, new papers are still being prepared, And as of right now, in 2026, nobody can say with certainty what that mysterious signal actually is. That's the real reason this story matters. We've mapped Pluto's surface, we've flown past it with a spacecraft, we've studied its haze, its moons, and its thin, leaking atmosphere. And despite all of that, there is still something down there that we genuinely cannot identify, hiding in plain sight in the light itself. So here's the question I want to leave you with. What do you think that unknown molecule actually is? Some undiscovered organic compound formed in conditions too extreme to replicate on Earth? Or something else entirely, something that might force scientists to rewrite what they thought they understood about chemistry at the edge of our solar system? Drop your theory in the comments below, because this mystery is far from solved. And if this story fascinated you as much as it fascinated me while researching it, do me a favor and hit that like button. It genuinely helps this channel keep making videos like this one. Subscribe if you haven't already, because as new data comes in from Webb's ongoing observations, we'll be covering every new development the moment it happens. 3.7 billion miles away, a tiny frozen world is quietly holding on to a secret that modern science still cannot name. And somewhere in that faint, distant light, the answer is waiting for someone to finally figure it out.